Electric fields and potential difference, as the heading suggests. As you're aware, a mass in a gravitational field experiences a force, and that force is in a specific direction, and a mass above the surface of the planet Earth experiences a weight force directly downwards. The directly downwards is the direction of the gravitational field. With regards to electric fields, these are set up and do exist around charged particles. I've drawn on the board an electron and a positive particle, possibly a proton, and I'm just going to draw the field patterns that exist around these particles. Now, as you can see, the patterns look the same. Right? Both of these particles are spherical and they have what's called a radial pattern as for the field around it. However, the direction, like I said, the gravitational field acts downwards on the planet Earth, and both these charged particles will require to show the direction of the field. So the negative the direction is towards, and it would stand to reason, hopefully, that you'd appreciate that for the positive, the direction is away. Now, the direction for any electric field is the direction that a small positive particle would move when placed in that field. So if I placed a small positive, then it would be repelled in that field, whereas it would be attracted in that field. So the direction is all to do with positive particles. Now the diagram on the extreme right is what I'm trying to represent as two metal plates. Now you can set up an electric field between two metal plates by putting a specific charge on the plates, for example. Circuit's been set up in such a way that the top plate is negatively charged and the bottom plate is positively charged. So again, the reason for doing this is to set up an electric field between the two, and this electric field has a pattern. Again, the direction shows the direction a small positive particle would move if placed in that field. Now, hopefully what you can see with the field lines as I've tried to draw them, they never touch, they don't cross over. So that's crucial for questions when you're asked to draw electric fields around particles. Now, moving on, well, just before we do go, any particle that's placed in an electric field, any charged particle that's placed in an electric field experiences a force. That means that it accelerates. That also means that to move a charged particle in an electric field requires work. So work has been done on the charged particle as it's moved around the electric field. For the term potential difference that we haven't discussed in the past, it's important that you appreciate what the definition of potential difference is as a two-word term that's effectively going to replace voltage. Potential difference of a supply is a measure of the energy given to each charge carrier in a circuit. You may recall that the energy to move charges in a circuit is provided by a power supply or a battery. Without the two of them, you can't have a current flowing, with regards to us at National 5. So whatever the voltage of that supply is, 12 volt supply attached to a lamp or a 6 volt supply attached to a lamp, a 12 volt supply will make the lamp shine brighter, because each charge carrier in that circuit, according to this statement, receives more energy. Now volts is the unit for potential difference, but because of the definition of potential difference being a measure of the energy given to each charge, then it can also be defined as joules per coulomb. So the basic example I've got, 1 volt is defined as 1 joule per coulomb, or 1 JC to the negative 1. Now just as a little example, there's very few questions specifically on these. Little example there on potential difference. I've drawn a series circuit. Now still to move on to circuits, but in third year when you did do electricity, you should appreciate a series circuit. Got a supply, DC, a lamp and a resistor, and I have written on it 3 specific positions, A, B and C, and the voltage measurement taken at those specific points. And potential difference is as easy as its name suggests. The question's there that says potential difference between A and B, B and C, A and C, not too difficult. Not anything that's going to tax you. A and B is literally 2 volts. The difference between B and C, C is 8, B is 2, 6 volts, and finally between A and C, C is 8, A is 0. You literally subtract the small from the large to find what the potential difference is between 2 points. So for example, any charges moving between B and C will receive 6 joules for every coulomb of charge.